So I've used this Fisher brand marking pen. This is specially formulated to mark really well on glass and also to not bleed when we do all these washes, the washing antibodies over the microscope slides, etc. So we've got these special pens, and I've marked an X to indicate the slide that we're going to do negative control and have no primary antibody, and name for where you would put your name and your antibody's name and what kind of the name of what kind of tissue it was, like axolotl regenerating limb. And so we would label these with what we wanted, what the tissue was, so that 5 years from now, a student that wasn't even you could come and pick up these slides and say, oh, I know what's on these slides, and look at them under the microscope and see what your results were. So careful labeling of the slides is important. I have gone ahead one step without you to make the sandwich. So there's my block of tissue. I just turned this upside down and popped it out. And I put it right onto my chuck that had a little mound of OCT, and I added a layer of peanut butter or jelly, whichever you prefer, to the middle to hold those two pieces of bread together. So here's my sandwich. But I noticed that some parts of the sandwich are sort of hanging over, and I want to make sure that when I start hitting this thing with a knife, no part of it topples over. So I'm going to use one final layer. Hopefully, this is the messiest part. Okay, so hopefully I'll be able to be successful in my first try here. And just I want to add an extra layer of glue around the outside, just to make sure this won't fall off when I start hitting it with a knife. That side's pretty good already. Okay, so lots of OCT dripping everywhere, and I'm gonna quick put this onto the Peltier cooler, turn that back on, and especially because I was holding the metal with my hand, it heated up remarkably quickly. So I want to make sure to freeze that. The one thing that can go wrong at this step is that the OCT leaks off the side of the chuck, and then your chuck is frozen to the Peltier cooler. Yeah, that's not a pleasant experience of trying to pry that up with a screwdriver or something. So it looks like I didn't overdo the OCT, and that when that outer layer, that ring that I just put around, is done, we'll be able to go straight to the next step, which is called trimming the block. So we'll give it just a minute to freeze, and I'll put the OCT back in the refrigerator because we are done with it. Go ahead, that's it. So I've got our window open. Let's reach back in here and turn the Peltier cooler off. And here's our frozen sandwich with peanut butter spread all the way around the outside to make sure the sandwich never falls off. I'll place it in the chuck holder and tighten that down so that the chuck cannot move in any direction. Notice I've got my two pieces of tissue. When I had them in here, we had it towards the bottom. On the right was the regenerate. It's flipped like that right now. Actually, I think I would prefer to cut it this way. When the knife comes up and through the tissue, okay, it's nice to have extra OCT after you've cut through your tissue. So what is this now? This is flipped this way. So notice the larger piece of tissue is on the right, that's our stump, and the smaller piece is the regenerate on our left. So we can keep that orientation in our mind. I've got both my slides ready, but we're not ready yet to start cutting this because we got so much more OCT than we need. So let's take our friendly neighborhood razor blade, the one that I'm not afraid to hold with my hand, and let's do what is called trimming the block. So what I'm going to do here is I'm going to cut away small bits at a time of the extra OCT. Now as long as I've got a good solid sandwich there, I'm not going to knock the tissue off the block. So let's say I took my microscope slide and I put a piece of tissue on there. I could only fit like 3 of those pieces of tissues on the whole slide. You want to get a minimum of 10 tissue sections on every slide. Otherwise, you won't have a good number of samples to compare with antibody staining. So I'm not going to only just cut the extra OCT off the top here. How about I also cut off the side? There's extra OCT there. So what I want my knife to do is only give me a piece of OCT that is just barely surrounding my two pieces of limb tissue. And that will give me the right size block so I can fit multiple tissue sections, even multiple rows of tissue sections on the slide. So now I'm cutting away from the left side, and now I'll even cut just a tiny bit from the bottom. Since I already put them towards the bottom, I'll be cutting less off of the bottom than I do off the top. Let's pause. So I'm done trimming my block. I would say I over trimmed it here on the top because we can actually see the tissue from the top. We only want to be able to see the tissue from each side. So this is going to be a much smaller block, and notice how that will be pretty easy to get multiple sections on multiple parts of a single slide. So the next step will be for me to be brave and get the knife back in there. So make sure this is loose, slide the blade in, only touching the back side of the blade. It's now in the knife holder. There's the blade in there. And tighten the knife down. So now I do not want to reach in here and touch past that line. This right here is a roll guard. When you shave ice, it curls. As you cut it, there's pressure, and then in the area where it's exposed to the air, it's melting, and so it curls. So we don't want our tissue to curl, we want it to lay flat on our microscope slide. So we're going to slide our little cutting of ice underneath this glass and onto the metal plate. But if you watch me right now, notice I'm nowhere close to this tissue hitting the chuck. So luckily over here we have some additional buttons that can move our chuck forward, the chuck holder forward, more than just 20 microns. So if you film real close right here, watch and see if you can see it moving as I press these buttons. Can you see it moving closer towards the blade? Oh, it's getting pretty close. So I'm now just gonna use the slower forward button. Okay, I'm almost touching. So now I have a lot less than a millimeter to go. So I can just crank and crank and crank and crank and crank and crank. That little popping noise that you hear is a rubber at the back that keeps all these little shards from getting into the workings of the machine. So it's just flapping back and forth. I just taught in my intro bio class about the epiglottis. So that's what I'm thinking of right now. The epiglottis covers your the entrance to your lungs so that you don't drink water or swallow food into your lungs. Just a little flap back there. Oh, do you see the first snowflakes? Every time I turn the crank, this is moving forward towards me by 20 microns. And this right side of the block happens to be sticking a tiny bit taller, not enough that I could see it with my eyes, but enough that the knife is cutting the right side of the block without touching the left side. Now I've gone through enough times that it's cutting the whole block. My block's starting to get a little dirty, so I'm going to leave the chuck below the blade, and I'm going to grab a paintbrush. Yes, a very dirty, rusty old paintbrush. This job of the paintbrush is to just push away those snowflakes so that I have a clean working surface. So now what I'm going to do, oops, I got another snowflake there. The blade does not cut on the way up, but there was a snowflake stuck on the top of the blade, so as it passed, it got stuck on the bottom of the blade. So I'm going to put the roll guard down, and let's see what we can see as I much more slowly crank this block past the knife. Well, I know what happened. I bet you guys couldn't see it. The shaving of ice was blocked by the side of the glass, and it didn't go under the glass. It just got repelled, just rejected. So all it did was it just curled up right there at the front of the knife. But notice there's a black line in there. Do you have enough zoom you can see the black line? Right there. That's our piece of stump tissue. And that on either side is just OCT. There's no black line over here, so we're not into the regenerate tissue yet, but we're already into the stump tissue. So I want to start saving these sections onto the microscope slides so that we have tissue on the slides and we don't lose all the tissue to cutting it on the knife here. But I cannot pick up one that has been rolled up already. The tissue will be folded on top of each other, and microscopy needs a flat piece of tissue in order to work. So what I need to do here is I need to adjust my glass so that's at a slightly different angle. So I'm going to bend it. There's a marker right here that indicates what angle the glass of the roll guard is at. So I'm going to change that angle a little bit so that there's more of an angle. So what happened on that last section is the tissue rolled up instead of going under the glass of the roll guard. This knob right here controls where this rotator is located, and I want the glass to move forward so it hangs over the edge of the blade. So as the tissue touches the blade, any tissue that's coming off will go underneath the glass. So can you see how, as I adjust that, the whole roll guard is moving further and further out over the knife? I want it to be just barely over the edge of the knife. This little knob adjusts the angle of the glass. This one right here. So I'm just trying to make sure it's lined up with the edge of the knife blade. So let's try to take a few more sections. As I was adjusting this, I moved the knife, and so I need to move the chuck forward until it starts hitting tissue sections again. We should get a snowflake here. Pretty soon there's some snowflakes. And there's a whole section. So take my paintbrush, wash away that section, and now set this down, and let's see if we can get a flat section to go right under the roll guard. Get all the parts in the exact right position. Nice tissue section. So I'll take my slide, turn it upside down so that the side I've written on is the side that's going to face down and pick up the piece of tissue. Now I have to do this relatively quickly, and my hand will probably be partially in the way. So what I'm going to do is lift the roll bar out of the way, so the roll guard will come up, and then I will press this down on the metal plate, and quickly, I'll show with my left hand. Okay, I'm going to push it down till it picks up the piece of tissue, and then lift it up again. I'll try it once with my left hand. I don't care if I mess this one up. Okay, move this out of the way and pick up the piece of tissue. Oh, I did pretty well. I can do that with my left hand, no problem. There's our piece of tissue. If I have a black background, can you see it? Yes. So 2 pieces of tissue side by side. The bigger one is what? Good thing we had them separate. We know that the big one is our stump, not our regenerate. So now I'll put the roll guard back down. I'll grab the wheel, and it goes up, moves 20 microns forward, and slowly down, 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 and you can see the next piece of tissue slide right under the roll guard. So it took some fine maneuvering of me to get this glass roll guard in the exact right place. But now, all I had to do was roll the wheel, and it made 2 perfect sections. Now, the first one I put on my negative control slide. Now, this is only 20 microns next. So in salamanders, they have very large cells. This could be the very next cell over, which, if it was part of the blastema, it's still going to be part of the blastema. If it's part of the muscle, it's still going to be part of the muscle. So now I'm going to pick this next one up left-handed. Come on, Randy, you can do this. On your marks, get set, go. And there's my tissue section. 2 pieces of tissue side by side. Our 2 slides look identical. So next I want to go back. Well, I can see some snowflakes there. Let's make sure they're out of the way before I take the next section, because those snowflakes can be little bits of frozen OCT that can act like a speed bump. And then as I try to cut the piece of tissue, it'll get snagged on that and won't be completely straight. So I want it to lie flat, so I'll take the next section. Nice, it's just rolling right under the roll guard. Now that one, I think I did a little bit too fast. When the leading edge hit, the leading edge started to curl up even under the roll guard. So you can see it's a darker white line, or a more opaque white line than where the tissue is further back on this side. So the more you do this, the more it becomes an all-day affair where you go super slow, until all the sections have been laid completely flat. Okay, so I'll get my next slide ready. Come on, Randy, left-handed, you can do this. Ambidextrous, boy. There's our next piece of tissue. See how many I can fit on this slide? I've even been putting them across the bottom because I think I can get a whole nother row across the top. So we could fill this slide up real good with lots of tissue sections. Slow, slow, slow. As I do this more slowly, what will happen is the ice, as it gets cut, will curl and then relax. And then curl and then relax. So by going as slowly as I can stand to do, I can usually get a flatter tissue section. I know I did it right-handed, but you can see the two slides are identical with 4 tissue sections. Going 1, 1, 1, 1, 1, 1, 1, 1. I'll do one more on each, just see if we run into any of the other common problems that happen on the microscope, so I can troubleshoot them for you. So, oh yeah, did you see the right side of that one? It did not keep going, because why? What did I not do that I should have done? I didn't wash away any snow. I didn't wipe away with this paintbrush any snowflakes that might have been there. I think this one is still flat enough that I'm going to go ahead and try to save it. But it's not nearly as good as the others. Yeah. Oh, that's terrible. Okay. I'm glad we recorded this one. That one's awful. Okay. So we've got 2 beautiful tissue sections of each of ours, and then we're missing all the tissue. Most of the tissue still stuck right there. So clearly there is too many snowflakes, too much frozen material stuck on my tray here, so I've got to get rid of all that so that the next section will come off much cleaner. Oh, you know what? I think I saw a little snowflake right up on the top of here too. I sure did. That could have been the one that was the problem. Notice that I'm always brushing away from the blade. If I was to brush back towards the blade, all of the hairs would be cut off in one try. So always brush away from yourself. Remember, that is an unreasonably sharp knife. It has to cut 20 microns thick. Of course it's super sharp. Oops, I better cut the next section before I try to pick it up. And I'll go fast to here, and then slow from here. Inch it under the glass. See if I can pick it up with left hand. And there you go. Perfect. So now when I'm comparing these and I put them under the microscope, I'll say, if I'm on this slide, I'll go, good section, good section. Oh, there's some garbage, but I can still tell that there was tissue there, and I'll just keep going to the next section. On this one, I'll have 3 good sections to compare to the 2 sections that are here. But I'll put the next section here, and I'll fill these slides up until they look like I've got a number of other ones that I've done here. Look how full that is. Sections all the way. Now, This was one I let students demo on. They didn't always put it on straight. How do you pick this thing up, right? Okay. Here's another one with multiple rows of tissue, right? Oops, I got it upside down. There's our tissue. So we'll just continue to fill this up until the slides have tissue all the way along their length. We'll make 2 rows of tissue, and then we can stain these with our antibody, comparing regenerating limbs to normal limbs, stump limbs, to see, is our antibody expressed in all muscle or only in regenerating muscle? Or is our antibody finding its target expressed only in neurons or only in the blastema? Which would mean it would be found in our smaller tissue section but not our larger one. Remember that our negative control will have no antibody on it, and therefore we shouldn't see the protein showing up anywhere. Even if it's there, we haven't labeled it. So our negative control versus our positive control will give us an idea of what the background looks like versus what our antibody actually looks like.